Here we have an exponential equation that we'd like to solve. But before we try something as tricky as this, let's take a look at something that's a little bit easier. Let's take a look at 3 to the x plus 2 equals 3 to the first. Well, these guys have the same exact bases. Since they have the same bases, all we need to do is set the numerators equal so that we have equality on both sides. Subtracting 2 from both sides, we get that x equals minus 1. This is the exact method that we're going to employ in this more complicated situation. We're going to find a common base and then equate the exponents. So what common base did I have in mind? Well, looking at these guys, it seems like there's a 3 lurking inside each one of them. So in other words, this is the same thing as 3 to the x times 3 squared to the 2x. 27 is 3 times 3 times 3. So 3 cubed to the x. Here's where knowing our exponential properties really come in handy. And if you're not quite familiar with them, there's a page on the website devoted to the exponential properties that you might want to review. But if you really know your properties down cold, looking at this will automatically make you want to multiply these two guys. So we get 3 to the 4x equals 3 to the 3x. So again, looking back here, we had one base on both sides. Here we have the same base, but we're multiplying. Can we combine these? Sure. There's another exponential property which says you can just add exponents when you have the same base. So this tells us that 3 to the 5x equals 3 to the 3x. Let's set those guys equal. Let's set the 5x equal to the 3x. Subtracting 3x from both sides, we get that 2x is equal to 0 and x equals 0. So for exponential equations, what you want to do is get a common base on both sides. And then once you have a common base, you want to mush the sides together so that you just have base to exponent equals base to exponent.